Hello everyone, welcome to UGC EPG Pathshala. I am Dr. Dilip Kumar, Assistant Professor in Geography, Shahid Bhagat Singh Evening College, University of Delhi. The current session is on spectral characteristics of water and relevance of remote sensing for hydrological investigation. Under this session, we will discuss on electromagnetic energy, spectral region and spectral signature, spectral characteristics of water, relevance of hydrological investigation. Let us start the discussion. Water in any form is the basic natural resource for sustaining the life cover 3/4 part of the earth. Earlier, it was thought that earth is present in sufficient quantity of water because it was renewed and balanced between availability and demand. But today, the scientists around the world are alarming bell of an impending water scarcity and various issues regarding the water resource. In this regard, remote sensing play an important role in water resource management, which include monitoring, assessing of water resource, watershed characterization and water resource development plan. The literal meaning of remote sensing is making observation from a distance. It is a technique to acquiring information about the earth's surface. There is a wide potential of remote sensing in hydrological investigation through the interaction behavior of the electromagnetic energy with water. There are different process and stages of water has been investigated through the spectral characteristics. Water on surface like river, lake and reservoirs, underground water, soil moisture, accessible as well as inaccessible areas where water resources are tied up as ice and snow during winter month, water at atmosphere and particularly good area to demonstrate the capability of remote sensing technique. Electromagnetic energy, spectral region and spectral signature. Electromagnetic energy refers to all energy that moves with the speed of light in a harmonic wave pattern and broadly include light, heat and radio waves on which remote sensing in totally depends on it, and propagated through the space in a sine wave with constant speed. The sun and the earth are two natural sources of electromagnetic energy, and two types of energy is available for remote sensing, i.e. one is reflected energy and another one is emitted energy. The electromagnetic energy has two fields, one is electrical and another is magnetic, consequently called electromagnetic energy. There are three measurements are used to describe the electromagnetic energy, such as wavelength, frequency and velocity. Wavelength is a distance between successive wave crest or trough and denoted by lambda, measured in meter, nanometer and micrometer. The frequency is the number of cycles of a wave passing through a fixed point on a given point, measured in hertz, corresponding to 1 cycle per second. The velocity or the speed of electromagnetic energy is equal to the speed of light, that is 3 lakh km per second. There is a relationship between the wavelength, frequency and energy in electromagnetic energy. Radiation. Shorter the wavelength, higher the frequency and energy. Conversely, longer the wavelength, low frequency and energy. When electromagnetic energy is categorized into the scale of wavelength is called electromagnetic spectrum or spectral band or spectral region. There are gamma rays, X-rays region, ultraviolet region, visible region, infrared region, microwave region and radio region. All the electromagnetic energy are not reached to the earth's surface or atmosphere is not transparent for all the electromagnetic energy to reach Earth's surface is known as atmospheric absorption region, that is 2.5 to 3 micrometer and 5 to 8 micrometer, and selectively transmit energy of certain wavelength known as atmospheric window in both situations, where we are interested in remote sensing for atmosphere and Earth's surface. See the table number 1 and the figure number 1. The spectral signature is a reflectance or emittance of electromagnetic energy from the interacting surface material of soil, vegetation and water as a function of wavelength measured at different spectral ranges. On the basis of reflecting behavior of the material at particular wavelength is determined to identify different material of the surface. The spectral response, spectral reflectance and spectral emittance measured by the remote sensor used to sense the type and condition of feature. Once these responses are plotted on the each scale of the wavelength referred as spectral signature. The spectral characteristics of the water. Water has different properties from soil and vegetation. See the figure number 2. Therefore, water appears distinctive on most of the satellite imagery. Basically, electromagnetic energy incident upon a water body is subject to absorption, reflection or transmission by the water and further scattering by particles suspended in the water. Consequently, interaction behavior of the various wavelength of electromagnetic radiation with a different water form, quality and quantity. The visible wavelength of electromagnetic radiation absorb very little amount, which is less than 5%, and rest of the radiation is reflected back or transmitted. But near infrared region and mid infrared region, the radiation is strongly absorbed by water, leaving very little radiation to be either reflected or transmitted, resulting sharp contrast between land and water resources. The water appearance blue or bluish green due to strong reflectance at shorter wavelength and darker or black in red or near infrared wavelength. There are three major factors such as depth of water, surface roughness of water and suspended material in the water that affect the variability in reflectance of electromagnetic radiation. In the shallow water, the bottom of the water body is also reflecting the radiation, along with water appears lighter than dark, which appears in deep water. The reflectance from the surface of the water shows the wave pattern or wind prevailing on water surface. The roughness of the water surface is also affect the reflectance behavior of the electromagnetic radiation. In the smoother surface, the light reflected specularly, giving very high or low reflectance, depending upon the location or angle of the sensor. But in the rough surface, more scattering occurs, resulting high reflectance from water surface. There is various suspended material found in the water, such as sediments and chlorophylls. The sediments increases the reflectance in the visible energy that appears light in color. The water body such contain chlorophyll absorb blue and red electromagnetic energy and reflect green. Conventionally color photograph possessed some capabilities for penetrating water surface. The color of the water is due to the part of the solar radiation which penetrate the surface and is returned to the surface after selective scattering by the suspended particle or the bottom sediments. This radiation is predominantly from the blue and the green wavelength region, causing water body to appear various shades of blue and green. So, the color of the water body is determined by the volume reflection rather than water surface, which is scattered and reflected within the water body. The penetration of sunlight into the water body is greater in blue-green region rather than blue-red and infrared region, and it is influenced by two main factors such as clarity of water that absorb and scatter sunlight and suspended particle in the water that scatter, reflect and reflection of sunlight. Rayleigh scattering of the short wavelength by particle in the clear deep water appears blue or the blue-green color. Maximum transmittance of light by clear water occur in the range between 0.44 micrometer to 0.54 micrometer, with the peak transmittance at 0.48 micrometer, providing an opportunity for recording fast feature on the bottom of the water body is greater. In the red region, absorption of light is greater and only shallow feature can be detected. Water absorbed near infrared and middle infrared strongly leaves little radiation to either reflected or transmitted. These results are sharp contrast between any water body and surrounding land surface, providing to discriminate land and water only. The turbidity in the water which is suspended, such as sand, silt and clay, are change the spectral characteristics. These turbidity decrease the intensity of light and transparency of the water body, resulting reflectance of light in the visible region is increases, appears bright in the image rather than dark. When sediment concentration increases, the wavelength of peak reflectance is also shifting from blue region toward green region. The presence of large particles means that the wavelength of maximum scattering shift toward the blue-green to the green region. Therefore, as sediment content increases, there tend to be a simultaneous increase in brightness and shift in peak reflectance toward longer wavelength, and peak itself became broader, so that at high level of turbidity the color became a less precise indicator of sediment content. The wavelength outside the visible region have some advantage in the mapping of surface water. Being in the near infrared and continue through the longer wavelength, a very thin layer of water will absorb most of the incidence energy. The scattered radiation in these wavelengths is correspondingly less, causing clear water to appear very dark. On color infrared imagery and Landsat FCC, water show as dark blue to dark black. Radar images display water as completely black. All the transmitted energy is either absorbed by water or specularly reflected by the relatively smooth surface. None of the energy is returned to the receiving unit. The another point is relevance in hydrological investigation. Hydrology is the study of water on the earth, whether in the form of water vapor in atmosphere, flowing above ground as liquid, frozen as ice or snow in solid for, or retaining by soil as a soil moisture or underground water. Remote sensing provide a synoptic view of the spatial distribution and dynamics of hydrological phenomena, including water pollution, often possible by traditional investigation methods. Microwave and radar has brought a new dimension to hydrological study with its passive and active sensing capability, allowing the near real-time image acquisition to include extreme weather condition or seasonal or diurnal darkness. The capability of remote sensing in hydrology can be explained under three heads such as water in the atmosphere, water on the earth's surface and beneath the earth's surface. Now the water in the atmosphere, water vapor. Number one, detection of water vapor in the atmosphere is also important for the water resource because water vapor play a key role in hydrological cycle. It is possible to detect with remote sensing technology from water vapor absorption band, particularly around 6.7 micrometer wavelength. And Meteosat, a geostationary satellite launched in 1977 by ESA, that is European Space Agency, with MVIRI sensor, that is the visible and infrared imager. This sensor has water vapor band that is 5.7 to 7.1 micrometer. Meteosat 8 MSG-1, Meteosat second generation satellite with SEVIRE, that is spinning enhanced visible and infrared imager sensor, has channel 5 water vapor 6.2, that is 5.35 to 7.17 micrometer, and 6 water vapor region 7.3, that is 6.85 to 7.85 micrometer. It provides continuously of the Meteosat first generation broadband water vapor channel to measure mid-atmospheric water vapor and to produce tracer for atmospheric winds. GOES is the another satellites that provide water vapor information. It provide information at 6.7 micrometer region, but MODIS provide the water vapor information in the near infrared region of the spectrum, including band 17, that is 0.89 to 0.92 micrometer, band number 18 0.931 to 0.941 micrometer, and band number 19. It is a region where the solar radiation is strong and interference from other atmospheric gases is weak. The span of water vapor wavelength region is 0.89 to 0.99 micrometer. There are three major water vapor absorption band such as strong absorption band centered near 0.942 micrometer and weak absorption band centered around 0.906 and 0.977 micrometer. The information about the cloud in the visible and the thermal infrared spectral region is used for the cloud information. In daylight, cloud appears bright in visible region, satellite imagery, then the land and water feature on the Earth's surface. GOES satellite and the Meteosat geostationary satellites provide information in visible and near infrared region imagery. They use to monitor frontal system intense thunderstorm such as hurricane and tornado. In general, cloud do not reflect solar radiation equally well all direction. Therefore, a single measurement of reflectivity from a single direction make it difficult to determine the total light reflected by the cloud relative to incidence energy. Solution is to obtain multiple images of the cloud from different vantage point. The EOS satellite, that is the Terra MISR, collect stereoscopic cloud information by viewing each cloud from 9 angles. The MISR data can distinguish different type of clouds, aerosols particle and surface, as well as analyze to yield 3-dimension quantitative information about the cloud height, structure, thickness, shape and roughness of cloud top. The precipitation. The remote sensing is also used in estimating the precipitation. In the initial stage, indirect methods were used in the visible and near infrared region such as cloud reflectance, cloud top temperature, etc. The reflectance from the cloud appears bright in the imagery and assumed that brightness of cloud likelihood of bearing rain, but all bright cloud could not precipitate. Similarly, temperature of the cloud top was used to determine the precipitation. Basically, cooler the cloud top, likelihood of precipitation, but all cold cloud top not precipitate. The direct method of precipitation estimation by the use of active and passive microwave sensor, which is sensitive to detect ice and water particles within the cloud. Conceptually, precipitation size ice particles and raindrop significantly reduce emissivity of the cloud and thus reduce its brightness temperature to below normal background level for computation of rainfall estimate. The special sensor microwave imager has been carried on board Defense Meteorological Satellite Program near Polar Orbiting Satellite since 1987. This sensor included a high frequency channel at 85.5 GHz band with vertical and horizontal polarization. Spatial resolution is 15 km and 13 km. Could distinguish rainfall over land. Tropical rainfall measurement mission satellite launches on November 27, 1997 carried TRRM microwave imager, that is TMI, passive sensor among 5 onboard sensor, that is the visible infrared scanner, light imaging sensor, precipitation radar and cloud and earth radiant energy system, which is best emitted for rainfall estimation over ocean at tropical region. The precipitation radar provide the information about the rainfall actually reaches the earth surface operating, whereas passive sensor, that is TMI, have differently to measure rain over earth surface. It also provide 3-dimension map of storm structure. These measurements yield invaluable information on the intensity and distribution of rain, rain type, storm depth and height at which snow melts into rain. After 17 years of TRMM service was end. Further, Global Precipitation Mission is a core observatory satellite launched by a consortium of GPM partners in the United States, Japan, France, India and Europe for rain and snow measuring. The GPM constellation of 8 or more satellites can observe precipitation over the entire globe every 2 to 3 hours. The GPM core satellite has 2 main payloads such as GPM microwave imager, an advanced large aperture 13 different channel passive microwave rain radiometer to observe energy from the different type of precipitation through cloud for estimating heavy to light rainfall and snowfall. Dual frequency precipitation radar provide 3-dimension information about precipitation, especially size of precipitation, particles width in cloud system. The Ka band scan across a region of 125 km and is nested with the wider scan of Ku band of 254 km. Water on the earth's surface. First we will see the surface water. Remote sensing is widely applied to discriminating the land and water feature. The near infrared and the mid infrared energy is absorbed by clear water, resulting dark color appears in the imagery. Thus, identification and distribution of water body on surface in any form such as river, lake, pond, ocean, etc. is very easy and first step toward hydrological investigation. The monitoring and assessment of surface water resource, either seasonal or yearly, can be done directly with the help of temporal characteristics of the satellite. Oceanography and the marine resources. The measurement including sea ice, temperature, current, suspended sediments and water color. Only satellite remote sensor can determine currents synoptically over extensive ocean and coastal region. Satellite altimetry is one of the essential remote sensing technique for monitoring dynamic ocean condition, including surface currents, local wind speed and significant wave height. Satellite altimetry measures sea surface height, providing data on geostrophic circulation, including measure ocean current. Ocean current can also be determined by the satellite. Synthetic aperture radar or tracking the movement of thermal and the color feature in the ocean. The flow pattern of current like the Gulf Stream are being mapped with satellite infrared scanner. The water surface temperature. Remote sensing is only way to get information about the surface temperature of the water. It may be inland water surface temperature or the sea water surface temperature. Collect during daylight and night time using the thermal infrared energy. Heating and cooling behavior of the water is very slow than land surface, as well as temperature difference between day night is very less. In water body, resulting water bodies appears warmer and cooler than surrounding land surface during night and daytime respectively. The remote sensing satellite NOAA-AVHR the sensor, and NOAA GOES data has thermal infrared instrument used to measure sea surface temperature. Landsat thermal band is used to map small water bodies such as reservoir, ponds and lakes. The groundwater identification. The assessment of subsurface or groundwater is not possible directly with remote sensing, but it is an economical source of reliable and real-time data acquired for various studies involving various land surface features such as land use, land cover, drainage network, hydrogeomorphological mapping that include the geomorphology, lithology, structure, which are important parameter to derive the groundwater potential zone. The hydrological analysis from the satellite imagery provide the information about the groundwater resources as applied in Rajiv Gandhi National Drinking Water Mission. The integration of various thematic information such as lithology, structure including lineament, fold, bedding, geomorphology and hydrology include rivers, ponds, reservoir, canal, spring, rainfall, irrigated area, wells and water reservoir structure for measuring the groundwater resources. Identification of the soil moisture. Air occupy the space between the soil particles during dry condition of the soil called interstitial air space due to the groundwater rise or due to precipitation or irrigation. Infiltration process occurs and that space between the soil particles are occupied by water. So, the soil particles are surrounded by a thin layer of water known as a soil moisture. Again, the amount of moisture is depending on the texture of the soil. The fine soil texture has more capable than coarse soil texture to maintain water as soil moisture, resulting higher moisture content in fine soil and absorb more radiant energy and less reflected energy. The measurement of soil measurement by the measurement of the soil moisture by remote sensing produce the spatial coverage rather than local as conventional method. In the visible region, increasing spectral response by fine and coarse texture soil, but increases in the soil moisture decrease the reflectance from soil. In the infrared region, water absorb band at 1.5 micrometer, 1.9 and 2.7 micrometer exist and absorb the incidence energy produced dip in the spectral graph in this region. Water quality. Water quality describes whether or not water is suitable for a specific use or whether or not the surrounding environment may be endangered by pollutant in water. The water pollution can be divided into the two sources. One is the point source pollutant, and where the sufficient discharge through pipes and open channel from human habited area, industrialization and wastewater. Another is the non-point source pollution or diffuse pollution, which normally occurs from rainwater runoff. Monitoring and assessing the quality of the water are critical for managing and improving the water quality. In situ measurement and laboratory analysis of water sample are accurate for point of time and space, but they do not give either the spatial or temporal view of water quality needed for water management purposes. Remote sensing play an important role by its characteristics such as synoptic coverage, multi-spectral and the temporal near real-time information for groundwater quality assessment and monitoring, particularly for non-point source pollution. Visible spectral region can be used for total suspended solid detection. Reflectance increases with the increase in sediment concentration, water transparency, color, chlorophyll, algae blooms. Aquatic vegetation of eutrophication can monitor through the use of color infrared wavelength region. The oil slick create film on the water surface can also detect from satellite data. It can be detectable in visible near infrared wavelength band and radar imagery. The thick oil slicks appears brown or black color in imagery, but the thin slicks appear silvery or rainbow color on the water surface. The irrigation water management. The optimum allocation and economic use of a crucial and scarce input like irrigation water is lifeblood of agriculture. The remote sensing technology significantly provide information on irrigation command area for various crop during different season has become very easy, accurate as well as cost and time effective. Promising technology provide information of irrigated land, identification of crop type, their extent, crop condition and production estimation. Inventory of different source of irrigation such as canal and their leakage detection, tanks and ponds with dry or the perennial condition can be mapped with remotely sensed imagery. Injudicious irrigation lead to ineffective water management, resulting the soil problem like salinity, alkalinity and waterlogging have been mapped and monitored with this technology. Irrigation scheduling is also important for the water management, and it can be optimized by information about the soil moisture and the crop condition over the wide area. The conventional irrigation scheduling using crop, soil and meteorological parameter resulting limitation in rapid assessment of crop water stress. The conjunction of remote sensing and conventional method can overcome this problem. The measurement of temperature by infrared thermometry provides the measurement of crop canopy radiation temperature, which is directly indicator or crop water stress. Conceptually, when the plant water potential is high, the transpiration is more, which means plant temperature is higher than that of ambient air and vice versa. River morphology. River morphology is a science of form produced by the action of flowing water due by the process of erosion, transportation and deposition. The synoptic coverage and the temporal resolution of remotely sensed data is help in river pattern identification and the river meandering channel in channel flow, extent of flood and their damage, water logged area, floodplain features and delta. The major changes in river form such as migration of sandbars, changes in bank line, reconstruction of paleochannel can be monitored with as quantitative evaluation such as river length and width can be done with the temporal remote sensing imagery. The geoengineering investigation, identification of suitable construction site for engineering structure such as dams and barrier across the river valley for the irrigation and electric power generation is another avenue of the remote sensing application. In hydrology, the information about the different perspective of terrain and physical characteristics such as geology and the lithology of the area provide the information about the construction snow. Assessment of the snow cover area and their depth is important parameter to determine the runoff after snow melting. The standard snow survey provide limited sample while remote sensing system can provide comprehensive data in computer compatible format in rapid analysis. Snow was the first observed by the satellite in eastern Canada from the TROS-1 satellite in April 1960. Since then, the potential for operational satellite-based snow cover mapping has been improved by the development of high temporal frequency satellites such as GOES, Landsat, SPOT and IRS series have been used for snow line determination and also snow cover estimation in the basin. The IRS series snow is very distinctive feature that can be detected readily with a variety of remote sensing technique. Various wavelength bands are sensitive to different snow properties. Snow has a very high albedo in the visible region of EMR. In the visible band 0.4 to 0.7 micrometer, a strong reflectivity contrast between the snow and the non-snow area exists, which facilitate the mapping of area covered by snow or the non-snow region. However, in many cases, snow and cloud cannot be discriminated in a visible region, became both has very bright reflectance. The near infrared region do not possess such strong snow reflectivity, but can be traced to the occurrence of surface melting, which is important for runoff or a break up forecasting. Though in visible and the near infrared region, snow and the cloud reflect about equal amount of radiant flux. In middle infrared region, particularly the 1.55 to 1.75 micrometer and 2.10 to 2.35 micrometer wavelength ranges are very useful in discrimination of snow and cloud. At this range, snow has a very low reflectance while the reflectance of the cloud remains high. Therefore, both cirrus and optically thick cloud can be directly classified and distinguished from snow at the 1.6 micrometer. Thermal observation of the snowpack in the thermal band can be used to delineate the area covered by snow because of the temperature contrast with the snow-free area. Temperature of the snowpack can never rise above 0 degrees Celsius. This can be used to identify when the snowpack surface reaches 0 degrees Celsius could possible by melting. Flood mapping and monitoring. Every year, many river and the stream spills their banks, inundating cities and agriculture field, causing the loss or the damage to the public and the private properties. Here, remote sensing can be used for monitoring and extent of flood and provide data for stream flow routing. It provide information on flood inundated area and different magnitude of flood, so that the extent of flood can be related to the flood magnitude. Duration of flood can be monitored by the multi-temporal coverage of an area. High resolution satellite data provide the information on floodplain and detail of flood control work. By using the contour information on the floodplain can be used for flood risk zone mapping. The microwave sensing provide the vital information during the flood begins visible, and infrared sensing cannot provide ground information during rainy season due to the cloud, and microwave sensing can be used effectively since it has penetrate capability through the cloud. The drought. Remote sensing of water and vegetation on the earth's surface and combination of weather parameter can provide the vital information about the drought disaster. Vegetation is only land category known to strong absorb the visible light and high reflect and transmit in the near infrared reflectance, popularly known as the vegetation index, which help in monitoring the photosynthesis active vegetation. Numerous vegetation canopy parameters such as LIA, biomass absorbed photosynthesis, and related with vegetation index. This physical principle is used in rapid crop condition assessment from satellite observation for drought condition monitoring, early warning system, and damage assessment. Remote sensing through its characteristics of synoptic coverage, near real-time information capability, and different resolution, the spatial, spectral, temporal, and radiometric characteristics provide an important information to detect water resource at different form. In the initial stage of remote sensing technology, it was only applied for the surface form of water detection and discrimination of land and water feature only. But with the passage of time, it is utilized in almost every component of hydrological cycle, such as water in the atmosphere, surface, subsurface, and ocean. It can also helpful in various kind of hydrological investigation, such as watershed characterization, groundwater modeling, river morphology, flood, drought, soil moisture, water vapor, rainfall, etc. Thank you.